Hi, everyone. So I think we are already running late behind the schedule. So I'll be giving a very short lightning talk, but this is not going to be a very React specific talk, but kind of front-end system design. So hi, I'm Deepak. I'm a software engineer at Airmeet, working in the platform team. And so if you know, Airmeet is a virtual event hosting platform where we host events like this, where multiple people, multiple tracks can run like this. Okay, so there are different capabilities when you are working on a uh, like doing a multiple like online event, right? So you can do chats, questions, reactions. You can join me on the stage by raising the hand. So doing these things at the very large scales, like at scale of 100,000 user at the same time, is very crucial, and it has a lot of challenges. So I'll be talking about those challenges today. So the talk is building scalable real-time front-end applications. What are the challenges? So let's get started. First, what are the real-time applications? Okay, just give me a second. Yeah, okay. What are real-time applications, right? So real-time front-end applications, as I said, it's all about instant experience, like how you can manage the experience. And if, for example, how you're making the things real time. So let's say that if there is any update happening, for example, if someone is doing a chat, someone is posting a questions, how quickly you are able to send to the end user, and how quickly you are able to interact with that. That's what is about real time. So for example, in this case, let's say there is a database here. I'll just give in context that there is a database, multiple people are connected, multiple users are connected to this database and doing the activity. Someone is sending a chat. So real-time experience using the WebSockets and bidirectional data things. Whenever there is an update happening in the database, all the connected users are getting the updates at the same time. So it's like message delivery is almost instant in the real-time applications. And we use Firebase real-time database, the commonly used database, or the CouchDBs. The few examples can be like YouTube live chat. So for example, you can see that how if someone is posting a chat, the experience is almost real time. You can get to see the masses, and the data streaming is very fast. Okay, so collaborative editors and the tools like Google Docs, Canva, or Figma. You can take an example, right? So let's say that if you're building a systems like Figma, and uh, if the updates are happening, you are doing some activity, and if the updates are happening at a very after some time, the experience is not gonna be good, right? So for that, the experience has to be almost real time. There should not be any latency, even if thousands of users are connected to the applications. Okay, so these are the few examples like multiplayer gaming, live trapping, financial applications. One of the use case we have in Airmeet is we have built, for example, in the break, a lot of people were connecting and talking to each other, right? So what if this experience is happening in an online environment? In that case, we have built a space where you can join the space. A lot of people are on the screen, like a lot of people are on the screen. You can go to that room, and then you can just go to someone nearby and then start a conversation. So what happening behind the system is that whenever you are going to someone nearby, basically you are streaming your data, and then we are starting a conversation based on the proxy, like you are nearby, right? So this is a very good example of real-time applications. uh, Second, okay, so basics of real-time application is that data sync is happening across all the clients. In the last example, if we see, data sync is happening, which means if I am moving, the other person is also able to know that, okay, this person is nearby, and I'm able to start conversation in almost real time. There is no gap, there is no delay in that. So the basics of real time is that data syncs across all client is happening in real time. Then the commonly used protocols, for example, let's say you are building in weather API, weather application. What happens? You have to make an API call to the server. You are getting the data, and then after some point, so there is some latency in that, right? In case of real-time applications, the basic protocols, like widely used protocols which are used, is WebSockets and HTTP pollings, right? In WebSockets, basically the communication is bidirectional. you're sending a message, you will receive in almost instant, like other person who is connected to the channel will receive in instantly. HTTP polling, so it's like an HTTP API call. You will keep polling the server for any updates, and then you will get the data. Okay, then let's talk about an example. How we can build what are the challenges when we build a real-time applications, okay? So let's take an example of chat application, simple chat application, nothing fancy, like there is no WebSocket, there is no scalability. We have a front end, we have a backend, we have a database. I'm sending a chat message, data is going to the server, and whenever I'm making an API call that, okay, I'm sending a chat message, posted data. So the server is pushing the data to the database. Someone is requesting after, let's say that this client is making the call every 1 second that give me any new update. It's reading the data, server is reading the data from the database, and it's delivering to the front end user. But what happens, let's say that if 1,000 people, 10,000 people get connected to this system, do you think that this server, this database, and this single database, any kind of database of the server has some kind of capacity, right? So how single database or how single servers, how the front end is going to handle, we will talk about those challenges. Let's see that, like, what are the challenges? First is concurrency, as I said. Okay, what happens if 10,000 people get connected to the system? Obviously, there will be issues. Let's talk about these issues. For example, if you start messaging like this on the YouTube, obviously, like you will have very bad experience. Like your front end will be like, okay, I'm getting the messages, the front end, the messages are going up, I'm not able to see any messages. You have to use, like, you might have used pagination or data limiting, how much data you are reading on the front end on the at one point of time. So those things you have to optimize. Then again, there will be server load, that if you are sending the messages very frequently, or like you are abusing the system by just sending like something random, okay? Increased latency, we will talk about this, how it causes increased latency. You might not be, this is kind of a very like database concept. Like, so we'll talk about this, that how sending multiple requests or how sending too many messages or events are causing the increased latency and performance issues. So next thing, this is an example of the YouTube. For example, if I send too many messages, there is a this is the kind of message I get in the YouTube, that okay, you can't send too many messages, you need to slow down. And this is kind of the optimization YouTube has. Okay, so if you're sending too many messages, basically they throttle the request, you can't send messages. So these are the few things you can do to tackle these challenges apart from the server issues. So this is not happening on the server. This is just a front end change, that okay, if I'm sending too many messages, just block the request. You can't send too many messages at the same time. Okay, let's talk about what happens if one user was connected. What was the issue? But what if 100 users are connected to the same system? What's going to happen? For example, this is a database. 10 users are, let's say 10 users are connected across this database. This is a real-time database. So every database has some capacity, okay? So whenever I'm sending a message, this user is sending a message, instantly the data, instantly all the 10 clients are getting updated at the same time, which means that there are 10 reads. So database performance is basically like measured with the read and write, how much read and write you are doing at the same time. Okay, so at one point of time, if this user is sending a message, then 10 reads are happening at the same time. What if 10 users are connected and 10 users are doing the chat send at the same time, which means 10 into 10. So it is like all the users will receive 10 messages, which is going to be 10 into 10, which is 100 reads. So it'll be 100 read per second. But what if 10,000 users are connected? Sorry. Yeah. What if 10,000 users are connected and 100 out of that 100 users are sending the messages at same point of time? So if you have to deliver this kind of messages, and if it is instant, they're gonna be 10,000, like 100,000, like no 1,000, like 1 million reads per second. Okay, and one of the famous databases for the real-time communication we use is Firebase real-time database and CouchDB. For example, taking the reference of Firebase real-time database, it has at any point of time, it can have an active connection of 200K, 2 lakhs, and read limit is 100K. So if you are using Firebase real-time database, you can have like after 100K, you will start facing the latency, which means that latency means the messages will be sent to the queue, but it will be delivered after some time, after 1 or 2 seconds. Okay. So for this, for handling this much traffic, again, you have to make, if one database instance is able to support 100K reads, 10 database need to be able, we require to make support of like 1 million. Okay. So, and then this is again the concept of database replication. So for example, if I was sending to, initially the front end was sending to just one database, server was sending to one database. Now it has to be on the multiple database. It has like lot of complications, and not complications exactly, but configurations you have to do from the server, like shardings and replications, these concepts, once you like deep dive into the system design, right? So there is a master database and then is replica database. So if we are building a system like this, the data syncs across all the client has to happen, and it has to happen in the real time so that users will not face any issue. So let's say that if I'm building a system like virtual event solutions like this, take an example of Airmeet. We currently have scale till we can host, recently made our a lot of improvement, and we can host up to 50 to 100,000 users at the same time. Like they can do a lot of activities, like you can host hundreds of sessions in parallel, you can send chat messages. So if you're building a system like that, you have to make sure that the data sync is happening, and you cannot compromise with the latency, which means there can't be any delay. If there is a significant delay, if you are sending someone a chat message and they are receiving after 10 seconds, or let's say that I'm on the stage, I want to invite someone, they're raising their hand, and I'm getting the reason after 10, 15 seconds, how is gonna the experience look like? And let's say that if I'm inviting someone on stage, so these are the functionality real-time event tech solutions have. So if these kind of latency will be there, obviously no customer is gonna buy that. It's not gonna work, right? So you have to make sure the data sync is happening in real time, and the data sync is consistent. So again, like this is a very deep concept. We won't go about how the sharding and replication and consistency is happening. But yeah, again, the data syncs and data synchronization is one issue we already talked about. If you are debugging something, a lot of times happen. If you are working on something, if it has microservices, it is connected to multiple database, and if it is kind of you have multiple database instance, and there is some bugs is happening because of inconsistent database, same thing gonna happen. I have faced a lot. Okay, so yeah, the quick recap. High concurrency is the issue. We have to face, like you have to scale your system accordingly if a lot of users are coming at the same time and joining at the same time. Front-end performance optimizations, like if users are sending messages at very high speed, or too many messages are getting sent, how you're handling the pagination, how you are reading the database, how you have improved your rendering techniques, that whether the updates are not happening too frequently, or like how you're doing it right. Data synchronizations, communication protocol, you can use like long polling WebSocket. WebSocket is preferred if latency, if you want to decrease the latency. Database scaling challenges. Okay, yeah, so any questions till now? Anything? Okay. So again, like whatever the challenges we talked about, we will see what are the architectures we can follow and what we can do to scale our systems. Okay. So scaling front end. Yeah, like without breaking anything, if you want to, we will talk about what are the challenges and what are the systems. So this is just an example of the Airmeet system. It has different multiple speakers. I have joined it using 2 links. I'm sending chat messages, so user can send the chat messages. And if in an event tech solutions, these type of events, these type of sessions can run in parallel. This type of multiple sessions can run in parallel, right? So let's say that I'm on the stage, people are voting at the same time, people are sending chat messages, someone is reacting to the session, and same time. So I have did a load test to show the demo that how it works and how is the experience going to look like if you're sending too many messages at the same time. And if I am sending again my message is getting lost because I'm not doing, like, I have removed all the optimization, that like throttling and all, I have removed that to, so that how it's gonna look like, right? Reactions, chat messages, polls, everything is running at the same time. And if you are sending at this scale, the reaction has to be like, the event delivery has to be instant, like this. Like the polls were updating at the same time, the chats were updating at the same time. Even the user when stays, nobody was facing any issue. Okay, so okay, so for scaling the front end, again, that's what we talked about. You have to choose the right protocol, like WebSocket or long polling. Again, it has like different pros and cons, but yeah, we use WebSockets for the communication. Second, for example, if you are using, even in the, this is an example of YouTube. If you go in the YouTube live chat, it does not show you all the messages. Okay, like if you go in any stream on the YouTube, it will show you just 100 or 200 messages, because even YouTube cannot handle that much scale. If you saw the YouTube live, YouTube like section, it doesn't update very instantly, right? It updates after some point of time, let's say 10 minutes, 5 minutes, 15 minutes. Okay, so this is an example of YouTube live chat. If you are sending too many messages, they throttle the messages. They have pagination, they have limit that you can only read 15 or 20, like 150, 200, 300 messages one point of time. And yeah, like these are the things front end handling में real time applications you have to do. Second is optimistic rendering. So for example, what happened if I'm sending a chat message, I'm at a very large scale, like the system, a lot of chat messages are coming, but what if my message was not sent? So what we do is that first we send the message, like also for the event delivery. For example, I send my chat message, it goes to the front end, and again I have to show to this UI, right? So this UI is reading the data from the database. I am getting some message, like 10 messages came. I am showing on the my component is getting the data and showing on the front end. Okay, what happens in the optimistic rendering is that whatever the self message you are sending, you can ignore the message when it is coming again from the server. Let's say that at every point of time, every second, I'm getting 10 messages, like 10, every point of time, I'm getting 10, 15 messages from the server. And I have also sent a couple of messages. In that case, what happens? I'll ignore my messages because I have already rendered on the front end. And then I'll just get whatever the other messages, which were not mine. Okay. So that's how like optimistic rendering works. And if let's say my message delivery is failed. So you might have seen that we show on the red, like if it is not sent or if it is in the retry, we keep showing in the gray, like you might have used Slack or something, right? So if the message delivery is not successful, we keep showing in the gray screen, like gray text. If it is completely sent, we show in the like white color or something. And if it is the event delivery has failed, we show in the red color, right? So these kind of things. And in that case, the optimistic rendering works. Yeah, I think that's all about the front end part. Second is, yeah, so data synchronization. I'll talk about a little bit more about the Airmeet, right? That how we are handling 100K concurrent users. So for example, just like you, I'm here the speaker. You guys are attendees, right? Even in the Airmeet or the any virtual platform, most of the people who are joining as viewers. So they are not very much doing any activity. They are just as a viewers. Okay. So I have to make sure that the data happening on the, like I have multiple replication. Okay. So just, yeah, more concurrent users, more reads per second, more database instances I would require, right? I had to make sure that if the whatever updates I am doing as a speaker or as a host, as an organizer, it should reach to the viewers as well. And whatever the attendees are doing, it should come to the organizer or the host as well. So the replication has to be in such a way that the replication should be, data should be consistent. Okay, so we made something like this, that okay, all the attendees will be connected to one kind of shards, replica slave shard, you can say that. There is in backend, if you see, there is a setup of master and slave shard. So master is basically the main copy. It has multiple backups. And again, the slave shard is basically the copy of the master. And replication is happening across all the shards, so that data will be consistent across all the shards. Okay, so what we have done is that in order to improve so that nothing can happen, even if something is happening on the slave shards, my host and my event should not be affected. Okay. So let's say that if something happened on one of the slave side, few thousands of users can face the issue, but event will keep on going, right? So we have like connected in such a way that host, organizers, speakers, whoever are basically the action takers in the event, will be connected to one kind of database, and whoever are the viewers in the event will be connected to a one kind of setup, reads and writes. To scale the reads and write, again we talk that it has to be real time. So if you are crossing a certain limit, in that case you have to make the replica of the databases, right? So again, master and replica, and the data sync is happening across these using some mechanism we can't reveal about. The backend part might not be relevant to everyone here, because I know this is not a very React specific talk, but you have to choose databases which support high reads and write. And again, after that, there can't be a single database which can take like millions of requests or millions of reads write per second, right? There is not a single database. Vertical scaling is never a solution when we are building scalable solution, right? So you have to have some database which supports high read write, and if you're going beyond a certain users, you have to do the replications and the shardings, like multiple horizontal scaling, you can say that. Then for the messages which is getting sent, so if you're handling at a scale of thousands of and millions of users, you have to use massive queue for the processing, like Kafka, adding database replications, horizontal scaling, and the load balancing we use for the maintaining the performance, so that right set of users is connected to which database. This is need to be make sure. So yeah, that's all about it. I think even if it is not on the React, but I hope you had a good learning experience or some kind of new experience. So thank you. Any questions?